Inside this rolling mill, solid steel slabs weighing tens of tons are transformed into sheets thinner than a coin. Everything begins with heat, pressure, and precision. These slabs arrive thick, rigid, and unyielding. By the time they leave this facility, they are flexible coils moving hundreds of meters per minute. This is the full industrial process that turns red-hot steel into ultra-thin steel sheets. The process starts in the slab yard. Each steel slab is identified by grade, chemical composition, and initial thickness. Carbon steel, high-strength low-alloy steel, and specialty grades are all processed here. Automated cranes and AGVS move slabs into position with millimeter accuracy. There is no manual lifting. Every movement is synchronized with the rolling schedule. Before steel can be rolled, it must be reheated. Slabs enter a walking beam furnace where temperatures rise gradually to over 1,200 degrees Celsius. This heat softens the steel, making it malleable enough for extreme deformation. Infrared cameras monitor surface temperature continuously. If the steel is too cold, it cracks. Too hot, and its internal structure degrades. Precision here determines everything downstream. steel heats up, oxidation forms on the surface. Before rolling begins, slabs pass through high-pressure water jets operating at up to 300 bar. These jets blast away scale in seconds. Without this step, surface defects would be rolled directly into the steel sheet. Clean steel enters the rolling stands. Now, the steel meets force. In the roughing mill, massive rollers compress the slab repeatedly. Thickness drops from over 200 millimeters to around 30 or 40 millimeters. Each pass elongates the steel dramatically. What was once a short slab becomes a long, glowing strip. Rolling force, speed, and gap are adjusted in real time based on steel grade and temperature. This is where brute force and control collide.
The thickness is dropping below tolerance here. Should we intervene?
No, the predictive algorithm anticipates the correction. Let the automation compensate.
steel strip now enters the finishing mill. Here, it passes through a series of closely spaced rolling stands at extreme speed. Thickness is reduced further, down to just a few millimeters. Hydraulic systems adjust roller gaps thousands of times per second. Profile, flatness, and edge shape are constantly corrected. By the time the strip exits, it is no longer a slab. It is hot-rolled sheet steel. Immediately after hot rolling, cooling begins. Rows of water nozzles spray the steel strip in controlled patterns. Cooling rates are adjusted precisely to control the steel's microstructure. This step determines strength, ductility, and toughness. The wrong cooling curve can ruin an entire coil. Steel science happens here, in seconds. While still hot, the steel strip is wound into a massive coil. Each coil can weigh more than 25 tons. Coiling temperature is tightly controlled to prevent cracking or internal stress. These hot coils are the starting point for ultra-thin steel. Hot rolled steel still carries residual oxide. In the pickling line, coils unwind and pass through hydrochloric acid baths. The acid dissolves remaining scale without damaging the steel underneath. The strip is then rinsed, neutralized, and dried completely. Only perfectly clean steel can be cold rolled. Now comes the most extreme deformation. Cold rolling squeezes steel at room temperature using enormous rolling forces. Thickness drops from around 2 millimeters to as little as 0.2 millimeters. The steel hardens as it deforms. Roller pressures reach thousands of tons. Thickness tolerances here are measured in hundredths of a millimeter. This is how steel becomes ultra thin.
Check the tension levels on line 3. We are seeing a fluctuation.
Confirmed. Adjusting the roll speed now.
Cold rolling makes steel strong, but brittle. Annealing restores balance. The steel strip enters a continuous annealing line where it is heated to 700 degrees Celsius in a controlled atmosphere. Internal stresses relax, grain structures reform. Steel exits flexible, uniform, and ready for shaping. Final light rolling pass follows. This skin pass improves surface finish, flatness, and mechanical consistency. Only 1 or 2% thickness reduction, but critical for quality. This step ensures steel will behave predictably in stamping, bending, and forming. Before shipping, every meter of steel is inspected. High-speed cameras scan the surface for scratches, pits, or cracks. Laser systems measure thickness and flatness continuously. Defective sections are flagged automatically. Only coils meeting strict standards move forward. Finished steel strip is recoiled, strapped, and labeled. Each coil carries detailed production data, grade, thickness, and processing history. From here, steel sheets are shipped to automotive plants, appliance factories, construction sites, and manufacturers worldwide. This is how raw steel slabs become ultra-thin steel sheets with heat, pressure, precision, and relentless industrial control.